From the previous slides, it's clear that the near wall modeling strategy needs to be selected before the mesh is created. So during the pre-processing stage, we need to know what distance from the wall for the first layer of grid cells corresponds to the target value of y plus so that is suitable for the strategy that was selected. This can be complicated because y plus is dimensionless, but the grid is not dimensionless. So what we want to do on this slide is show an example of how to estimate the physical distance from the wall that corresponds to a given value of y plus. When we do this, it's important to remember that the actual flow field is not known until after you computed the solution. So this is just an estimate, but you can definitely reduce the risk of needing to remesh by estimating the cell size using the procedure that we show here. So we want to start by we can do this by performing hand calculations, and to illustrate this we have an example where we have a 1 meter long flat plate and air flowing at 20 meters per second with the physical properties that we see here for the density and viscosity. For demonstration purposes, we've decided that we want to use wall functions. Standard wall functions is what SWF means, and we want our value of y plus to be about 50, so we need to figure out what height y away from the wall we need the grid to be so that we get y plus equals 50. The first thing to do for any flow calculation is to calculate the Reynolds number, and so when we do that, the Reynolds number is about 1.4 times 10 to the 6th. And we remember from an earlier slide that the flow over a surface is turbulent when the Reynolds number is bigger than about 5 times 10 to the 5th. So the flow here is definitely turbulent, and we can move on with the y plus estimation. This slide shows an example of how to estimate the value of y plus. The starting point is a definition of y plus, and we rearrange this because we know y plus. What we're trying to find out is y, which is the distance from the wall. So when we rearrange this expression, we have y plus times the viscosity divided by the friction velocity times the density. We know our target value for y plus, so what we don't know is the friction velocity. The definition of the friction velocity is the square root of the wall shear stress divided by the density. So this means that what we really need to figure out is the wall shear stress. And we can estimate this using the skin friction coefficient. You can just see the definition of the skin friction coefficient is shown here. And if you look in a heat transfer or a fluid mechanics text, you can find that a formula for the skin friction on a flat plate in terms of Reynolds number is given by the expression that we see here in the lower part of the slide. This expression is for boundary layer flow on a flat plate. If you're doing internal flows, there's similar expressions that can be found, as the footnote there indicates. So then we just work backwards from here. We put our Reynolds number into the definition, into the correlation for the skin friction coefficient. We get a value for the skin friction coefficient. We put that back into its definition, and that gives us the wall shear stress. Then the wall shear stress goes back into the definition of the friction velocity, and that gives us the friction velocity. So now we have everything that we need to know, and we plug these into the formula here and get that the wall distance should be about 9 times 10 to the 4th meters in order for y plus to be 50. So our first cell height should be at a value of y plus equals about 1 millimeter. An important thing to note is that when you're using Fluent, the cell height y is equivalent to the distance of the cell centroid from the wall. So that means if you're using ANSYS meshing, the first grid point should be at twice the cell height. Another thing to point out is that if you have to do this calculation a lot, it can be handy to keep a spreadsheet where you just plug in the values of Reynolds number, density, viscosity, and y plus, and then it does all this calculation automatically for you and spits out the wall distance that you need for the target y plus value.